it over for a rebuild. That's what I was doing when I first started in security. I've done threat hunting, threat intel, and currently right now I work for CrowdStrike, and the team that I'm on, we do remediation every day. So we, have customers and monitor the console, configure the console, and do all of that. But if something happens, if we see something that, got past a tool or whatever, we'll go in and actually do remediation. So we do this all day, every day. Love it. Just one of the things that I found that I really like about this particular job is that you see some really interesting techniques that attackers use to gain persistence, stay there. Some of the techniques that they're using are pretty cool. I'm going to talk about one of my favorite persistence mechanisms for malware. And it's a really, really stupid malware. It's just a clickjacker. That's it. It doesn't do anything other than that. But it uses some really awesome and tricky technique to launch and maintain persistence. So I'll talk about that. So if you want to follow me, I'm at BWonderbread. So a little bit more about this talk is just moving beyond, just simply rebuilding. You have an infection. Sometimes, when I first started, I didn't even know if the machine was actually infected. Like, this triggered an alert. It wasn't a false positive, thus rebuild. That was it. It's not a terrible way to go about doing it if you like spending a lot of money having your support teams rebuild things all the time. It was anywhere from 30 to 100 rebuilds potentially a month. So, and it depends on your environment too. Like, what are you, is it a sales environment, or is it like a franchise environment? Like, hotels are just notorious for just, the people that work there don't care. They don't know about computers. They're just trying to be courteous to their customers. They're clicking on stuff. They're doing stuff all the time. So, you can do this. You can move beyond rebuilds and actually dig in and remediate. So, what are some of the common concerns? So to remediate or not to remediate? When you go back to your organizations, you're going to have to argue, like, we don't have to rebuild. We can actually figure out what happened, and we can stop the process. We can stop the persistence, and we know confidently that it's not coming back. You're going to have to argue that, but you're going to have to come up against some of the typical arguments. So I'll talk about that. A little process flow. It's pretty straightforward. One of the things that, when you're doing this, you really do have to develop a remediation strategy for every type of malware variant that you see out there. You're not going to want to just go and start, killing stuff, deleting files. You've got to dig in and see what's all happening. Okay, here's the bad process. You don't just want to kill it. You want to go figure out, well, where did that launch from? What file is, being launched into memory? What's the persistence mechanism? And develop that strategy. And maybe along the way, you realize that maybe it's bigger than, what you thought at first. So you want to develop that strategy almost every time you're digging in on a host that's infected. And then I'll talk about, I have two different examples of malware, and it's just, kind of showing what just slides. If I have enough time at the end of this, I actually did find a VM that I had that's infected with TrickBot. So we'll go through that if I have enough time here. I probably will. That'll be fun. Live demo. So there are definitely some circumstances where remediation is not an option. So we'll talk about that, and then what to do afterwards. So target audience is pretty much anybody that is going to be in this room. Even tech support people. But if you're a SOC analyst, SOC leader, all the way up to your CISO, like, if there's any security executives here, have you ever looked at what the cost is to rebuild one workstation? And then amplify that every time you get an alert. Amplify that for every time there's a security concern. It's actually a lot. You have to, and what about the process when, let's say you're a SOC analyst and you find an alert, you send a ticket over to your support team. Does the host just go offline? Do you contain the host right away? In a lot of cases, no. You just send a ticket over and hope that it gets done. Well, what if it's Friday late? This system doesn't get rebuilt until Monday or Tuesday. Sometimes you have to schedule it out because they're a salesperson and they're on the road. They're like, I can't do this right now. I have a presentation to give or whatever, right? Or they won't respond to the tech support person trying to get a hold of them. Maybe they have to send their laptop in. I worked had locations all across the United States. One location, there was a guy in Nova Scotia, and he had to go back to the administrative branch, which was not in Nova Scotia. So it was like a 7-hour drive and a 13-hour ferry ride to mainland Canada, like, for a rebuild. That's not really doable, right? So how long does it take to do the rebuild. And is the system completely down, like it's contained for days? That's not conducive to business. So not only is this, good for your SOC analyst to learn, and develop and for your SOC leaders to empower your analysts, it's also cost effective to do this. Obviously there's some concerns, and I'll get into that here in a minute, but, definitely empowering your analysts to actually learn things along the way. How does this malware actually work? I'm learning stuff every day. So it's awesome. And, malware authors, if you know what our strategies are for rebuilding, or for remediation, then, maybe you can take something away from this and get a little better. So if you're a malware author, get better, because that makes me better and we'll all have fun. So some of the concerns, like, what if you miss something? Totally valid concern. I've missed things. I've remediated stuff, closed my ticket, and I get an alert again. And I'm going, what the hell happened here? What did I miss? And that's one of those that, like, for me, and I don't know how you guys are, but for me, it's like, if I miss something, I'm really digging in the next time. Like, I will absolutely 100% not miss it a second time. That's just, like, I won't let it happen, because I want to know, like, I didn't do what I was supposed to do, and I'm not going to let that happen again. So, missing something is a learning opportunity. If the situation is big enough, there's definitely, I'll talk a little bit about this, but, like, when does it become something that you don't want to remediate? Like, do you want to watch, should you watch the TTPs of the attacker, of the malware? What's it doing? Those are definitely decisions that you're going to want to make, along the way. That's why you develop your remediation strategy. And I'll talk to that as well. But, you've got a targeted adversary. Sometimes you're going to want to watch, a targeted adversary, but you've got a lot of problems at that point. Remediation is only part of that. So, yeah. So, and a rebuild is the only way to make sure that it's clean. That's false. I do this all the time. It's definitely not the only way. One thing you do have to have is a barrier to entry to this is some sort of process execution logging. So, Sysmon, I think it's built into Windows 10. I haven't used that personally, so I don't know how good it is or whatever, but you need to know, like, if malware launches, you're going to need to know what's happening in that process chain as it executes. What files is it writing out? What, registry changes, are happening and things like that. So if you have an EDR, if you have Sysmon, if you have, process execution logging to a degree, you pretty much have to have that. So there's a bit of a barrier to entry there. So if you don't have the logs, then you can't confidently say, I know all of the binaries that were written out of this malware, right? So that's a little bit of a barrier to entry there. So, all right. So quick process flow. So just validate it's an infection. I mean, that's step one. Is it infected? So you want to validate that. Once you've verified that, yeah, there's something running on this host, you're going to develop your remediation strategy. So that's actually my next slide. Next few slides, actually. So all of the things that are involved in, understanding what's happening on the host, what did happen, what's running in memory, all of that stuff, you're going to want to, develop the strategy there. So that's step two. Conducting the remediation, we'll go through that. Step three, and then validation. Validation is actually an interesting one because, you always have this doubt in your mind, right? Like, you have all the logs, you have everything, and you're like, but I'm human. Maybe I did miss something. So, validation sometimes comes in the way of, like, you just maybe need to reboot and watch what's happening there. If you have the logging, you have the alerting, you're there for a reason. You see if any of that is coming back after a reboot or something like that. I always go through and just I do the remediation, and then I look through all of the log data that I have again and the tool that I have. So I'll look through that and just kind of go through step by step, every folder, delete, whatever. I'll kind of go through that. Usually you can get a pretty good idea. You've got one malware family, what it does, trickbot, schedule task, run key. That you've got everything just because you've, run into this particular malware family before. So, remediation strategy, your initial triage. So there's a few things to developing the remediation strategy here. Your initial triage is basically your alert. Or whatever it is that tuned you in to go look. So initial infection vector, was it a phish? Was it an exploit? Was it a web shell? Was it, anything? What was that initial infection vector? You don't always have to know, but it certainly is good if you do. So if it's a phish, you're going to want to find the document. If you don't find the document, keep looking. Did the user delete it? Look for your delete event. If you have all that logging, you'll find a delete event on that file. So initial infection vector is definitely one of those that I try to find as much as possible. What's the system purpose? What's the primary user? In the strategy that you're looking at, is it a server? Is it a CIO's laptop? What does this server do? Is it a web server? So if it's a web server and things like commands just mysteriously start running, you're like, okay, well, it's maybe a web shell. Let's go look in the web directories for things that shouldn't be there. Yara scans for typical web shells or whatever you want to do there. So understanding the system purpose is absolutely going to help you, understand the attack. Was it a phish or was it an exploit? Is something running in memory? Is something, creating a scheduled task and deleting a scheduled task? That's all going to help. And if it's an important user, you might have this okay, I got to stop what I'm doing because this is a user that has the keys to the kingdom. So we need to, perhaps collectively bring minds together and say, how do we figure this one out, because maybe it's a developer and you're a gaming company and this developer is like the primary person that, does all of your main things. I don't know, but it changes your strategy depending on who the user is. Are you dealing with malware or is it hands-on keyboard? So if you're looking at a web shell, a lot of times that is kind of, hands-on keyboard, if you will. If it's just malware, that might change what you do. If you know that it's something run of the mill, commodity, maybe it's malware that you've never seen before. It's taking a tactic that, you've never seen before. But if it's hands on keyboard, maybe that's one of those where it's like, yeah, let's switch up. Like we want to see what the attacker's actually interested in, to a point, right? Like you don't want them to be interested in all of your healthcare data and then allow them to steal the healthcare data, right? So, you watch for, a period of time before you pull the trigger. Look at your network connections. Any of the, your logging should hopefully have, if this process launched in memory, what network connections did it make outbound? C2s, where did it communicate out? Can you determine the malware variants? A lot of times, Emotet is starting to come back now. We've missed you, Emotet. They took the summer off, presumably in Sochi or some other Russian destination. But anyway, if you could determine the malware variant, that'll help you, to develop your strategy and kind of understand what's going on, where you're going to need to look first, what you're going to need to do to remediate. So, and sometimes it's a matter of increasing the preventions as well. So maybe there's a really important host that doesn't have the right preventions enabled, or it doesn't have the right firewall rules enabled to, so maybe you could just shut down your, whatever port on the firewall to, make sure that this traffic just stops coming in and out, and you can remediate what's on the host. So increasing the preventions on the host through your tooling or on the network side or whatever you want to do, that's all kind of the initial part of things. So once you get on the host, so you've done the initial part, you're looking at all the log data, you're kind of trying to get an understanding of what's going on and what you're in for. Once you get on the host, running processes, persistence, binaries, any other files that might be there, like keylog files, config files, just stuff like that. And then, try to determine what the functionality of the malware is. Is it a worm? Because, if it's a worming type malware, like maybe you try to take action more quickly on the running process. So maybe if you know that this thing's going to move laterally, like really quickly, then kill the process as fast as you can. So that kind of helps you understand, what step you need to take if you understand the malware functionality. But really the remediation thing breaks down to the three things here, just process, persistence, and the binaries on disk. Conceptually, we talked a little bit about this, but what is the purpose of this malware? Like, if you can determine the variant, maybe that it's a banking Trojan, or maybe that it's a worm, and that's all it's really doing is trying to worm, from host to host. With TrickBot, TrickBot's malware that we run across all the time now. It definitely has the capabilities to worm, but it has all sorts of different capabilities. It actually comes with various modules. But one of the purposes of TrickBot, it's like, well, how long until they get Ryuked, which is a ransomware variant. So if TrickBot can worm its way around the network to try to find a host that's important enough for somebody on the other end, presumably in some Russian destination, gets an interest in this particular box and thinks it's valuable enough to ransom, they'll drop Ryuk on it and try to get you to pay the ransom on your important system. So, what is the purpose of the activity? Is it a targeted adversary? I mean, obviously, if you're in the banking industry, a banking Trojan, perhaps targeted, maybe not. But, maybe you're in a sector of like healthcare and there's, you know that you have a particular, APT 41 being, super interested in healthcare data. So maybe you're going to have to understand, conceptually, like, is this particular thing targeted? It could be APT 41 phishing. I mean, it's low level stuff. They don't have to exploit all the time. They phish. So, understanding whether it's or not, it's a targeted adversary is definitely going to help you out in understanding what's going on. And the strategy of everything. So watch and disrupt. We kind of talked about that, but also talked about your threshold before critical reactions. So maybe this is, a domain admin. So do you say like, hey, this isn't a normal run of the mill remediation. This is a domain admin. They've got the keys to the kingdom. Like we definitely need to step in and do something right away. But let's have a conversation. Like where do you say, raise the alarm bells for everybody to get involved. So conducting the remediation, basically, I say here in this, and then after, looking at this again, I kind of want to rephrase it. Like killing the process isn't always the first step because, actually just recently I killed a process and I was, doing my remediation and then all of a sudden the process was back. And I go look at the scheduled task and it's set to run every 60 seconds. So maybe the persistence mechanism of the scheduled task is more important than killing the process first. It just depends on the variant. That's developing that strategy and understanding. Like if I kill the process, it's just going to come back if I don't kill the scheduled task within 60 seconds. So, that's not always the first part. It's usually the first part. With this next slide, I talk about a malware variant Kofter. If you try to kill any of the supporting files or the reg keys, the processes will literally write them back. It's just, there's a process and there's a watcher process and they're constantly watching the things that it knows that should be there on disk. So it's watching that. If you delete a registry key and then you do another, reg query on that same key and it's just back. It's literally immediate. There is no wait time. It just writes it right back out if you delete it. So, a lot of antiviruses will kind of, try to delete a file or delete a registry key or something like that. But the, watcher processes just continue to write it back and it's just like a battle. With processes, you got process injection. So I actually, will talk about it a little bit later with, SVC host. So injecting into SVC host, is kind of a good way for malware to hide. I have a pretty good, command line that I'm going to show a little bit later to basically point that out. It's like, it's not even that hard to find injected processes, injected SVC host processes, I suppose. If you're injecting into like a normal explorer.exe, at that point, you might, kill a user, login session. But if the malware is injected into Explorer, you kind of got to do what you got to do. And don't always trust that like running task list or, git process is going to tell you that the malware is actually running in memory because malware can just unlink from that table. So when you run a git process, you're looking at like a table where all processes, when they launch, they say, hey, I'm here at this place, right? Well, that table's just a listing, it's like a directory listing, right? So if the malware just says, I want to unlink from that, then it's still running in memory. It's got this, carved out space in memory, but it won't tell you in a git process or a task list that process is running. So, don't always trust that you can see the malware actually running in a specific process. So Kofter, is a clickjacker. It is a very dumb malware. Like it's got a lot of super awesome techniques for what it does. It's kind of like a love-hate relationship with me because like it does some really cool stuff, but it's really dumb. So this is what a process tree for COFTR looks like. It starts in the registry. So the parent process of MSHTA here is going to be explore.exe. So that MSHTA launches and you're like, well, how did that happen? And then it launches PowerShell and you're like, that looks kind of bad. And then it launches regserve32, which launches 3 more regserve32s. And you're going, yeah, this is all sorts of not supposed to happen. So that's a dead giveaway right there, because none of this is normal. None of this. So we're going to go look at the the running processes for COFTR. So you've got regserve32. So a couple things I just kind of highlighted. Hopefully you can see this. It's running out of syswhile64. Like, why would a normal Windows process that should be running out of system32 be launched and running out of syswhile64? Like, no real like application does that. Nothing Microsoft does that. You're not even supposed to really see regserve32 load. Like, it's supposed to load something and go away. Like, if it's running in memory, that's all, already bad. And then you can see the launch time. So regserve32's, system process, launches, goes away whenever it's needed. And this is running, and it's well after any of the other processes like CSRSS that loads right when Windows starts. This one, is running at 8.5. Like this, I took this a long time ago, screenshot. But obviously it's loaded way after any other system process. So that's kind of, it's not a dead giveaway, but it's kind of, building your strategy about what, is this bad or not? That'll help you determine. So I dumped out one of those regserve32s and just did some good old fashioned static analysis here, strings. So if you just run proc dump against that process ID, or whatever, you can see here that there's just a lot of like IP addresses listed in process memory space. I just, grepped for IP addresses. That's kind of weird. The first one, if you can see it, is like http://185 blah, blah, blah /upload.php, Sweet. That's probably bad. So looking again, I was just doing this to, take screenshots and build this out. And I literally just grepped for .ru and found stuff. And I was like, oh, sweet. Okay. So I was literally like, I wanted to grep for IPs because I knew they'd be in there with the clickjacker, but I figured out why not, expand this if I can, and just did RU. Yeah. A few domains in there as well. So that was kind of fun. So I ran a netstat. So we talked about, looking at your, active network connections. Remember that 185? That was in the first, or the 2 slides ago. So you've got an active network connection going to, over port 80 to 185, 117, whatever. You look at who is, it's hosted in the Netherlands by some guy out of Dubai. All right. Yeah. And there's a lot of .ru's in there. So yeah, something really weird's going on here. Probably got something bad. This is a screenshot from the tool that I use. So basically task kill. So if you remember how there was 2 regserve32s there? If you run task kill on just one of them, the other one's a watcher process. It'll literally just start up a new process. What I did find is that you could do like task kill /p, PID, and then the process ID, and then just do /PID, and then the other process ID /F/T, and then that'll like kill both of them off at the same time. So that's pretty cool. Also, when you're killing malware, use /T. That's super important. It kills the entire process tree. So any sub processes off that, unless you're killing like explorer.exe, I don't know, maybe don't use /T in that case. But you could also use like PowerShell, stop process, or if you wanted to do the really long, obnoxious way, you could use get wmy_object. So, persistence. This is a really busy slide, but it's like the most important thing, because this is why like COFTR is really cool. So what happens is, have you ever said like, oh, you don't have Adobe and you download a PDF and it's like, how do you want to open this? Like, and then you associate a PDF file with Adobe or something like that, right? So when you do that in your user profile, it registers that, .pdf is associated with Adobe. So in the registry, it actually says like, I know how to open a PDF now because it points to, C program files, adobe.exe or whatever, right? So COFTR does this. So like the persistence mechanism is to set up a link file in the user's like programs, startup folder. So it says a link file to open this 8C112A file. That file has like data in it, but there's nothing in it. It's just a blob of file. But what it does is registers .8C12A in the registry as like a file extension, a file type. And then it says, eventually what I want to do is open MSHTA JavaScript, which is in that big bubble here. So whenever you open a 8C112A file, it says, I want to launch MSHTA JavaScript something. Like, that's pretty awesome. It registers its own file type in the registry to launch malware. And then the malware is stored wholly in the registry. This key, if you can see it, if you can't, then, sorry. HKey current user software /mvgb/dz whatever, that points to PowerShell. And then the PowerShell code is literally in that particular key. And that's how it's launching regserve32 in memory and clickjacking all of your things. So like, this is really cool. Like, yeah, I don't know. It's pretty fun to like piece all of this together because I didn't know how the registry worked like that before this. And, now I do. And it's awesome. All right. Maybe you guys aren't as nerdy as me on that stuff. All right. So here's the files that 8C112A, and that bat file, I guess, launches this. So maybe there's a link file in the user's startup, whatever programs, to launch this bat file. And this bat file just legitimately just calls this file here and it loads. So, what you do is just basically, so now what we do a little bit differently is instead of just deleting files, we'll actually save them off. So we'll like save them to a different folder, encrypt them, and then, with a key. And then we provide that to our customers. So like for your use case, if you work in an organization, like save this locally just in case you ever want to have the malware variant again. I think I've seen this before. Like go search your tickets, go hit the host, maybe even, copy them off to a directory that you save malware to. Every time you do a remediation, like instead of just deleting it or whatever, just go ahead and save it off. That's what we do now, which is good. So, Extreme Rat is a pretty standard rat. In this case, I just let everything be named extreme.exe, but you can change this to Explorer, SVC host, something random. It doesn't have to be like extreme.exe. When you download this rat and you customize it and install it on a host, you can make it say whatever. But this one actually injects into SVC host. So you can actually see that the tool that we're using gives you a little bit of an insight into what's happening here. So you have extreme.exe, launches extreme.exe, which launches SVC host and then loads extreme.exe into SVC host. And that, the extreme.exe, the second one there just goes away. Like it's already loaded in the SVC host memory space. So it's, this is like a process injection of, SVC host that is loaded from syswal64. So they loaded it up, and then injected their own, process into that. So when you do like a git process or something like that, task list, one of the things to look for is, so SVC host, obviously we're looking at the time that it started. It started at 8.7. All the other SVC hosts on the box started at 8.6. I guess this is the size or whatever, how much, memory space it's taking up is 9,000. That's way less than the other ones. Just kind of, building like this one's probably bad. The other one that you can't see there, I didn't get the heading, so I'm going off of memory here, but, 26, I think, is the amount of handles that it has open. But it's loaded from syswal64 and none of the other ones are. Like, it's already weird. So again, this is just kind of a slide that's more tool specific. Probably should take it out. But, this is basically saying like, I want to look for any SVC host that's from syswal64 and has a process ID of 2168. And then I just kind of like look at the tree again and confirm like my suspicion here is that the process ID of 2168 is the malicious SVC host and I want to kill it. But I want to make sure that I'm killing the right one because I don't want to bring down like the SVC host that houses your network connection, stuff in memory. So if you do that, you immediately lose your shell if you bring down the wrong SVC host, right? Or the user, can't use the system anymore and it reboots. It's going to hinder your remediation. So yeah, this is just killing this process. So the persistence mechanism, if you have logging for this thing, whenever extreme.exe launches, it's doing things like making registry changes, ASEP value updates, right? So you're looking in these locations, for, pointers of wherever files are getting launched from the registry, persistence mechanisms, right? So just removing those run a reg query and then a reg delete. Pretty straightforward. And then, cleaning up files. I kind of talked about that. I saw a DAT file here and I wanted to see what was in it. So I just, catted the DAT file. It's not always going to be like a binary blob or something like that. It could be just named DAT or something and have, keylogs in there or some sort of config that might help you understand what's going on. So I just figured I'd cat that. Didn't really give me anything. So I just just removed it. So how did this get here? I added this in kind of gratuitously just to show like event logs are important in this conversation too, because you have a successful RDP session here, 4624 with a logon type of 10. You can use just PowerShell, get event log, where object, the replacement string 8. That's actually a trick that I learned along the way. I didn't know how to do that at first. So I just filtered the script and told it to give me only logon type 10s. You could take that back. I actually use that from time to time, to find specific RDP connections. Sometimes you want to do like 2, logon type 2 versus, 10 or something like that. So that's a good one. And then in this case, you can see that the source address is 10 for whatever. That's not the local host, right? So you can chase down your RDP connection and find out where this came from. And then I just looked at like the event log view system 10 and AnyDesk was installed on this box. So AnyDesk was used to log in to this system remotely from that 10 for whatever. And that could be how extreme.exe got to that box. So just kind of, showing that event logs are kind of important here as well. So when is remediation not an option? Like ransomware. If the box is ransomed, I guess it depends because maybe you can find the key for that particular ransomware variant. I think there's an entire website. I don't know what it is, but it's specific to like all of the various keys that have been like reversed out of all of the various ransomwares that are out there. So you could just go to this website and find out, like, hopefully the variant that you've got hit with has the key reversed and you can just go decrypt. So maybe you can remediate if it's ransomed. Destructive malware like Virut, which is a file infector. So it literally like patches your SVC host. It'll patch your explorer.exe. It'll patch, any of the system processes, like task list. So every time you run task list, it actually launches the malware again. If it does that for all of the files within system32, like you just rebuild. Like I'm the person up here saying don't rebuild, like just rebuild, right? I did find Virut on a box one time and I did remediate it because it only infected like 3 files. So I just looked at the version of Windows it was and then downloaded those 3 files, off of another system, or you could get it off of VirusTotal and replace it. Like, it's the signed version. If you look at the binaries that have been patched by Virut, it won't be the signed version, obviously. So yeah. And then Shamoon, like the destructive RMRF type stuff. What are you going to do? Right. It's already rebuilt, okay. So whatever. So post remediation, obviously, what does the malware do? Have you been able to determine the variant? Do you know what that variant is capable of? Does it steal passwords? Does it steal credit cards? Does it worm? Does it take advantage of, like, is this particular variant that you're up against exploit Eternal Blue? Like maybe patch Eternal Blue. Yes, I still see that a lot. A lot of hosts have not patched Eternal Blue in this world. Believe it or not. That's not you, right? Nobody here. Everybody's patched that by now. Update firewall rules, depending on, how the malware came in. Did it come in through, attacking some sort of, open port where you had a service available and that, got through that way? Like, take a look at all that holistically. And NIST actually has a publication of all of the post remediation actions that you could possibly ever want. It's a very long and dry document right here. I tried to read it. I was unsuccessful, but yeah, there's a lot there that if you needed to reference it for a particular purpose, you could find what you needed there. So, that's the end of my presentation, but I think I have a few minutes, maybe 15. So I've got TrickBot live. So let's go look at that. So I was just playing around with it a little bit earlier just to kind of confirm that that it was like live TrickBot or whatever. So let's run task list and see what's running in memory. I'm just going to tell you now that you're not going to see any malicious running processes here because it's injected into SVC host space. So let's do this. This is the fun part. So like the Extreme Rat that I showed you launched its own SVC host and then injected itself into SVC host like that. What that does is essentially SVC host should be tied to a service. It's service host. That's what it stands for. So every time SVC host is loaded in memory, it should have some sort of service associated with it. So task list, if you do task list SVC, find string SVC host, so basically we want to have task list show us all of the services that are loaded at running processes, but also it tells you this is the DCOM launch service or the NetSVC whatever service or a policy agent or NA. Every single one of these is TrickBot because it loads SVC host and injects its process in there. You should never see SVC host loaded with NA. It's always going to have a service associated with it. So like these are all bad processes. It's a dead giveaway and it makes it super easy with TrickBot. And TrickBot's super active. Like in the wake of Emotet just being completely MIA for the entire summer, we saw a lot of TrickBot, which was, kind of cool, but it's a dead giveaway every time. Same with Extreme Rat in the example I showed a minute ago. So with TrickBot, if you look up any write-up on TrickBot or you've come into contact with it before, schedule task is the most common persistence mechanism. So let's look at schedule tasks. And if you did this, you'd get like a giant wall of command line text or whatever. What I like to do is do a find string for .exe, and it basically just shows you all of the processes that are called as associated by the scheduled tasks. So in this case, I'm going to scroll to the top and just kind of look through, see if I see anything that looks out of the ordinary. Did I scroll all the way up? Yep. It was here a minute ago, I swear. I actually don't see it now. I've left this running for a little while. Oh, nope, there it is. So TrickBot likes to run out of app data roaming. So I could do instead of do find string for exe, I could just search for app data, and there's my TrickBot. So I would go to app data roaming, win sys, and there's this is really old TrickBot. I had to go back into the malware VM archives. This is from November of 2018, based on the timestamps. Awesome. So it's kind of there for you. So TrickBot used to do these super long, random, numbers and letters. Usually the letters were all lowercase, but it'd be something super long. So you could even develop a script that looked for some sort of entropy, right? Like if there's a really long file name. So just recursively search through your user profiles for file names that are longer than 15 characters. And then it'll give you okay, it's app data roaming when ys or whatever. So that's one way you could kind of search this out. What else we got? So sometimes TrickBot does run keys. So I'm just going to look for the user profile. And in this version, they usually did just the user run key that was logged on. Now they're doing the default as well. So your default profiles. So anytime anybody logs in, every user profile is going to get, an app data roaming, WinYS, whatever folder. Actually, so I went into the directory above. So it's TrickBot's right there in app data roaming as well. So it's kind of sprayed all over the place at this point. So let's look at the registry. It doesn't always do a run key. It always does a scheduled task, but it doesn't always do a run key. Yeah, all of that is bad. So bundle XPath is Emotet. So I think what happened here was Emotet infected this box at one point in time, and Emotet and TrickBot were super bros. So Emotet would infect and just like worm around, and then all of a sudden TrickBot would show up. You're like, oh, okay, I guess Emotet, sold off their stuff. So at this point, I would go through and just do like a reg delete on, bundle X path. Actually, so one thing I didn't see was this. So mware ASP, that's a different directory. It's running out of AppData local Microsoft Windows. What's this Windows ASP? I'm just going to go check this out because that doesn't look good. Is that even there anymore? Nope. So that binary doesn't exist. Or that folder, it looks like a binary, right? Yeah. So I would delete that key for sure. It looks like everything in the run key. Just delete the entire run key at this point. If you delete the run key, it'll come back. It's Microsoft doesn't want there to not be a run key. I'd also be looking around at different places. Like in theory, I would have logs to tell me like, well, the only ASAP changes made were of the current user. So I would have that information in my back pocket, but I would also look in like the local machine. So I'm going to do that real quick. Okay, so it just infected the user profile. So, I mean, in theory, if you wanted to take like a blast approach, you could just delete the user profile and the scheduled task and be good. But you could, this is basically how TrickBot operates. So you kind of have that in your back pocket, So, okay, well, I guess that's it. I just kind of wanted to show you, just different stuff actually getting on the command line. I switch between just CMD, just regular, like old school command line and PowerShell. So sometimes when I'm building out like a remediation script, I want to do things like, I'll want to use PowerShell for where object a lot of times. So like where, last write time was in the past 24 hours. So that's actually a pretty effective tool to use is, if you get an alert and you go to a host, you're usually there within the same day, 24 hours, 48 hours, whatever. If you do like last write time, and look through like System32, C Windows, C program data, like just recursively search through C users or C users, Brandon Wunderle, like whoever the profile is, and then say last write time within the last day, you really narrow down the files that you're actually going to get a result back for. I mean, how many files are written that day in a user profile? Maybe a lot. Yeah, I mean, you could, a lot of temp files or something like that, but you could also, in your PowerShell command, do like where path does not equal temp. You can definitely narrow things down.